All right, welcome back. We're going to talk a little bit of atomic theory here, kind of review that a little bit. We covered this last year in regular chem. So the three main things you really need to be aware of, obviously, is electrons and protons and neutrons. Protons and neutrons are in the nucleus, and electrons are in those clouds. We'll get more of those clouds here in a little bit, orbiting the nucleus. But as far as historically, you should be comfortable with what led us to the development or the thought related to electrons, protons, and neutrons. And so you can go ahead and you have the notes here, but you want to make sure you concentrate and be comfortable with those three subatomic particles. And so you can go ahead and kind of take a look as far as historically, how far back we go. It goes back even a little further than this, but you can go ahead and take a look at that. With some concentration on electrons. And as we talked about last year, it makes sense that electrons were the first one discovered. They're the outside particle, and they're charged. So if anything comes in contact with the atom, that's what they're going to interact with. And they're a charged particle, so they can interact with other charged particles. And so the third page talks a little bit about the experiment that led to this. And you can look up cathode ray tube experiment online and kind of see a little bit more of the video. Look at my links or just do a general search. But they stripped these electrons, or they didn't know they were electrons at the time. They stripped these particles from the atom, set them across a tube that had gas in it. And when those particles interact with the gas, they let off light, if you recall the video from last year. And so the expected path was to go straight across. So that's your expected path. And again, we still have board issues, so I apologize. But when they actually put an electric field, kind of like a magnet, when they put an electric field on here, there's a negative field in this setup on top and a positive on the bottom. The particles deflected away from the negative field towards the positive. So that's a big piece of information. It told them, hey, those particles are negatively charged because they deflected down towards the positive. So a lot of work went into that. That's just kind of the highlights of that cathode ray tube experiment. So, like the problem with the theory column talks about, hey, now we're comfortable that there's some negative particles inside there. Well, if there's negatives, we know not everything in the world is charged. If things are neutral, there's got to be some positive. And so they did a little bit of additional work. We talked a little bit about the plum pudding model last year. Originally thought the positive charge was dispersed evenly throughout the nucleus. But the key experiment to be comfortable with and be aware of here is that gold foil. And I have some links to the gold foil videos if you want to take a look at those. Or if you just do a Google search or any kind of search on gold foil experiment, you'll come across some stuff on the web. But what they did, just a quick review, is they sent alpha particles, so they knew these were positive particles from a radioactive source. We'll talk more about radioactivity later on. And they went through a screen. So they sent them through, there's a hole in the screen, and then that screen lights up whenever one of those particles hits it. Okay? And then in the center, I know the image here isn't, it's kind of fuzzy, but you've got the original. In the center was gold foil. So a really thin sheet of gold foil, so they flattened it down. And so when they shot these alpha particles, or these alpha particles hit that gold foil, they expected them to go straight through. They expected them to go straight through and then have a whole bunch of marks back here in the back. Well, lo and behold, about one, give or take, about 1 in 20,000 or so, deflected. So it either came off to the side or came back towards them a little bit, or was deflected off to the side. Now, obviously, there's a ton of particles there, but that's significant. That's huge. And so what that told them is, number one, the fact that they were deflected, these alpha particles are going pretty fast. The fact that they were deflected, they had to hit something else that was positive because the alpha particles are positive themselves. So there's something else that's in there that's positive, and the fact that, strongly positive, and the fact that only 1 in 20,000 deflected said, hey, that positive is really small. So you got a really small, really dense, positive region in the atoms. And that's what led them to the nucleus. So again, two key pieces of information. The fact that they deflected said, hey, there's something really strongly positive in there, and only 1 in 20,000 says it's really small, really dense. And that's what led them to the nucleus. So that's a pretty big piece of information there. So at this point, again, we've got negatives and we've got positives. And positives are really dense, and they ended up determining those were the nucleus. But if those, so the problem at this point is if those positive particles are really packed densely and tightly, you know positives repel. Why is the nucleus stable? It should break apart. And so they did a little bit further work. I'm sorry, I kind of circled the wrong one. But those two kind of go together. So they did a little bit further work, and they did, determined or discovered the neutron, and that allowed us to account for extra mass. They were short a little bit of mass in the atom, and then also provides that stabilizing particle for the nucleus. So at this point, the board vibrated. At this point, our current atomic model, you should be totally familiar with this from last year. Protons, neutrons are in the nucleus, electrons are in those clouds. We'll get more of those clouds. Nucleus is very small. A lot of the atoms empty space. And to be neutral, you've got to have equal positives and negatives. So just a quick review of atomic number, atomic mass, and mass number. You need to be totally comfortable with that. Isotopes, we're going to deal a little bit with isotopes this year. So just a kind of quick review of that. The number up top is the mass number. I'm going to put a little arrow, maybe that'll be easier. So the number up top, the bigger number is the mass number, so that has protons and neutrons in it, whatever's in the nucleus. And the number down below, oh, this is really not working well. The number down below is the atomic number. Ooh. Atomic number. But you know what I'm talking about, really poor as far as the ability to be able to write on this board. So we'll see how it goes though. So, okay. So you need to be comfortable with determining a number of protons, electrons, and neutrons. You should be able to zip through that quick review from last year. So electrons, symbols E negative, negative charge. Protons P positive. Protons P positive. It doesn't want to write the positive. That's a positive. And then neutrons are N, 0. And 0 up here. Well, it doesn't want it in there. Location electrons, I'm not going to fill this in because it's obviously not having some issues here. Electrons are in those orbitals, those clouds outside the nucleus. Protons in the nucleus, neutrons in the nucleus. Mass, essentially electrons and protons. Well, we won't get into mass, don't worry about it. In charge, electrons -1, protons +1, and neutrons are neutral. So, okay. We talked about this and talked about the cold foil. So, okay. So, a quick review of atomic theory. Again, if you need to take a look at some links on my webpage, or go ahead and do a search on a couple of those topics online if you need to review them a little bit, or obviously come and see me. So, thanks.